Hello, I'm back for the second review packet for pre-calc for your final coming up. Now we're on to polynomials and rationals. All right, so it says consider the polynomial function. Now this one is expanded, it's been multiplied out. So to find the degree of a polynomial that is been multiplied out, look for the highest power. So right here, so it's a degree 47. The degree tells me the end behavior. An odd, the ends are going in opposite direction. Which direction is determined by this guy right here, the lead coefficient. So -6 with a 47 for the degree. So that is going like this. As I go to negative infinity in the x, it's going towards positive infinity. And as I head towards positive infinity for x, the function is headed towards negative. So I look at my little picture I drew. Okay. All right. Now this function is in factored form. So to get the degree in factored form, you add up the factors of each, add up the degrees of each factor. So this one's 3, 4, 5, 6, and then 4 more, 10. That's an even. Even functions, the ends are going the same way. How do you know which way, up or down? By the lead coefficient. When a problem is factored, to figure out the lead coefficient, just multiply the numbers in front. So that'd be -7 times 1 times 1 times 1. So this is a -7 x to the 10th if it was all multiplied out, which means it looks something like this. The ends are going down because it's a negative, but because it's even, they're together. So both of the ends are going down. Name any roots and state their multiplicity. I like to make a little chart. Roots, multiplicity. Okay, so the roots, whatever makes each factor 0. So the first one, 0 makes that guy 0, and it's got a 3 on it, so that has a multiplicity of 3. Next one, 4, and that has a multiplicity of 2, right here. -8 has a multiplicity of 1, and then the last one, -5, has a multiplicity of 4. The multiplicity tells me how the graph behaves at that root. So I'm going to go by 2's to make a picture here. 2, 4, 6, 8. 2, 4, 6, 8. I'm going to plot my roots. So I've got one at 0, I've got one at 4, -8, and -5. I know what the ends are doing. They're both going down. And then if the multiplicity is even, it bounces at that root. If the multiplicity is odd, it goes straight through. So at -8, so this one was down here, right? So it comes up. -5, it's even, so it's going to bounce. And then I'm headed towards 0, which is an odd. It's a little bendy. And then 4 is even again. This is just a sketch, not actually finding these values right here. But look, the ends are going down, down like we said. Okay? Next page, number 3. Here's another polynomial in factored form. What is the degree? Add up all the roots, add up the degree of each of these factors here. So 1, 2, 3, 4, 5. I'll write these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then it's the degree of that whole thing is 2. You don't add them all up. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So now the roots, we've got a lot here. So this one would be 0. This one would be -5. This one would be the positive square root of 10. This one, you would add 6. And then you take the square root, so you get 2 answers, plus or minus the square root of 6. This one would be -3/7. 2.5. This one, do the work here, x squared plus 81 equals 0. Subtract 81, square root, got a negative, so that is plus or minus 9i. And then this one, to find the roots, we're going to have to do the quadratic formula. X equals negative b plus or minus b squared minus 4 times a times c all over 2a. X equals negative 6 plus or minus, that's 36 plus 16, so that's 52 all over 2. You could clean that up. That'd be, this guy right here is 4 times, it's 52 divided by 4. So 2 root 13. So 2 root 13 for this. So I'm going to write this final answers. Negative 6 plus or minus 2 root 13 all over 2. Oops, I can still be simplified because 2. So actually, negative 3 plus or minus the square root of 13. Okay. All right, write a formula in factored form for a polynomial whose roots are negative 8, 1, and 3, and nothing else, and whose degree is 7. So 1, 2, 3, we're going to 3 roots. So it's got a plus 8, a minus 1, and a minus 3, and I need degree 7. Right now this is a degree 3. So answers could vary here. I could go 1, 2, 3, 4, 5, 6, 7. You could put lots of different powers on there to make it equal 7. Write a formula in factored form for a polynomial whose roots are 4, 0, negative 2, 1, and nothing else. Now this one, they didn't give me the degree. So you have some choice. So there, if a root is 0, that means there's an x with nothing in it, right? Well, you could put plus 0 if you really wanted. Then I have 1, 2, 3. 1, 2, 3. So that'd be minus 4 plus 2 and minus 1. And I'm not going to add anything because they didn't tell me what the degree was, so I'm good. All right, factor the following polynomial completely and then identify all the roots. So we can already see 2 of them clearly. This one is at x equals negative 3, and this one is at x equals 6. I could go write those right now. X equals negative 3, x equals 6. Now this third one would be a bit of a guess. I mean, looks a little bit less than a half. And I know this problem because it's a third degree, has 3 roots. So how am I going to find that one? And how do you factor a third degree polynomial? Well, we're going to divide it with one of these roots and get it down to something I can factor. So I'm going to use this one. So if it's touching at 6, that means the factor was x minus 6. Which, by the way, I can already write that too. Look, f of x equals 1, 2, 3. I could put x minus 6 and x plus 3 in. I need to figure out this one, which will then give me this answer. So I'm going to divide x minus 6 into the polynomial. So 4x squared, 4x to the third, times 24x squared. Subtracting, which changes the signs. Oops, that's 11. Oops. I'm going to have to let that dry for a minute. So that's going to be 11. So that's 11. So I know this is plus 11x. So that's 11x squared minus 66x. But I'm subtracting. That's negative 3x plus 18. Negative 3. And I know this better come out to no remainder because I know it's a factor. And if it's a factor, that means it divides in evenly. 11. I'll wait some more. Okay, so now look, we have a quadratic. You can do 2 things. You can either take this one and divide it by this one, or you can just factor this. You already know this is one of the roots. I'm going to go over here. I have 4x squared plus 11x minus 3. This one I know breaks down to 2 more, but I know one of them is that one, the plus 3. So I know this has to be 4x, and that has to be 1. And now look, 12 minus 1 makes 11. So see that one we already got. We use this one to divide, so there's the third one. 4x minus 1, which means the answer is a fourth, which that looks right, 1/4. Okay. Now we're on to rationals. So rationals, we added, subtracted, multiplied, divide, solved, and graphed. So here we go. Multiply and divide, the strategy is to factor everything and cancel anything that's in common, right? So this is y plus 5 times y plus 2 all over, we have a 5y times a y minus 2 times UCF of 2y, y squared minus 4. Then this one breaks down to y plus 2, y minus 2, all over. This is y plus 2, y plus 2. So then after you factor, you look for common factors that you can cancel, top to bottom, right? So a plus 2 cancels a plus 2, a minus 2 cancels a minus 2, plus 2 cancels a plus 2. And then I'm going to write it out before I clean up a little bit more. So I have 2y times y plus 5 all over 5y. And then these two can cancel. So my final answer is 2 times y plus 5 all over 5. All right, next one, divide. The only thing you do differently is you have to flip this, right? When you divide fractions, you're multiplying by the reciprocal. So this is going to be x minus 3 times x minus 3 all over x plus 1 times x minus 1 times, this is on the top, so that's a 2 times x minus 1 over an x minus 3. So cancel, 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 cancel. So this is 2x minus 3 all over x plus 1. All right, adding and subtracting, you have to have a common denominator. So I look, this one needs a 3n. I'm going to have to multiply that by a 3n. And this one needs an n minus 4. I'm going to have to multiply this one by an n minus 4. Once I get a common denominator, look, they match. So now I just rewrite it and I forget about it. Now, before I can add the tops together, I have to do all that multiplying. I've got to multiply that, and I've got to multiply that. So that's n squared minus 9n plus 20. You could do a box if you need to. Plus, this one is 6n squared plus 3n. So now I'm going to combine like terms. So I have 7n squared minus 6n plus 20 all over n minus 4 times 3n. All right, subtract. I need a common denominator. Let me factor this real quick. So I can see that this just needs an x plus 7. So, or sorry, minus 7. So now I need to multiply that by the top. So now I got my common denominator. Look, they match. So x minus 7, x plus 7. Forget about the bottoms. Now before you can subtract these, you've got to do this multiplication. So I'm just going to write this one down. Personally, I ignore the negative for a minute and I do this problem. So this is x squared minus 10x plus 21. But you're subtracting all of it. So all of these, the negative gets distributed to. This becomes negative x squared plus 10x minus 21. So now I combine like terms. I get x squared plus 5x, that is those two, that is those two, and then a 7, so minus 14 all over And then I notice, look at the top, it looks like, and I should have checked this one to see if it was factorable, because if this could factor and maybe cancel here, but this one, I just noticed because it's more simple, 7 and 2 make 5. So this is actually x plus 7 times x minus 2 all over x plus 7, x minus 7. So those cancel. So my final answer is just x minus 2 over x minus 7. Okay, to solve, there's different strategies. I teach clearing the denominator. So I notice in the denominator I have an n minus 8. So I'm going to multiply everything by n minus 8. So I'm going to multiply this by n minus 8, this by n minus 8, this by n minus 8. Okay, why would I do that? Because on this term it'll cancel. Here I'm going to have to multiply, and on this term it's going to cancel. No denominator anymore. So now what do I have left? 1, and then multiply that out, minus n plus 8 equals 7. And I'm left with an equation to solve. This is linear. So I'll put these two together. 9 minus n equals 7. Subtract 9 from both sides. Negative n equals negative 2. So n is 2. And then make sure that answer works. Like, remember, denominators can't be 0. So make sure your answer doesn't create a 0. That'd be considered an extraneous solution. All right, again, it's a solve. My strategy, clear the denominator. I'm going to factor this one so I can really see. Oh, both of these are minus. And not a 3, Miss Aspen. That's going to be 4 and 1, positive 4, negative 1. So it's the same as these. So I'm going to have to multiply everybody by these two. I'm waiting for that to dry. So x minus 1 times x plus 4, x minus 1 times x plus 4, x minus 1 times x plus 4. Why am I doing that? Because it's going to clear all the denominators out. So this one, the x plus 4s are going to go away. So I'll just have to multiply these. Here, the x minus 1s are going to go away. And I'll multiply these. And here, this is a plus 4. So everything's going to go away. So you don't even have to multiply the 15 by anything. So now we get 15 equals 3x plus 12 plus 4x squared minus 4x. This time, unlike this, we have a quadratic. So I'm going to have to get everything on one side. So I have 4x squared minus x. And then if I minus this over here, that makes a negative 3. And you could solve this by the quadratic formula or by factoring. I'm going to try factoring. I know this is 3 and 1, maybe the other way. Yep, it is. I could put the 4 here, so this is 4 and 1. Let's see. 3 and 4 make 1. Yep. I need negative 4 and positive 3. So that means my answers are 1 and negative 3/4. Let's check my answers. Oh no, the 1 would cause the bottom to be undefined, right? So this is considered an extraneous solution. So that is my only answer. Okay, last page. Nope, I'm a liar. Second to last page. So this one is a rational function of more complicated, and now we're kind of analyzing it, what it would look like, what features would emerge. We can figure those features out by factoring. So this is 3x times x squared plus 6x minus 27, which would then be 9 and 3. And then the bottom of this is x plus 3, x minus 3. So everything that we answer now can be answered from this. So the domain, everything's fine, but whatever makes the bottom 0. So all reals, x cannot be, -3 and +3, plus or minus 3. The asymptotes are created at these points, but notice there's a common factor. A common factor creates a hole. It still can't exist there, there's a hole, but it doesn't create an asymptote. So the only asymptote is at -3. The hole is at x equals +3, that common factor. The intercepts, the y-intercept is when x is 0 something. So you're going to let x be 0. So if I put a 0 here, I mean, hopefully you could see it, but I'll go through the motions. Those are gone, right? But 3 times 0 is 0. 0 times, this becomes 0 over 3, 0. The y-intercept is 0, 0. Now the x-intercept is something, oh, yes, when the output is 0. So I want to know what makes this, let me write it down, 0. I mean, you could solve it or you could think about this. The only way this can be 0 is if the top is 0, because 0 divided by anything is 0. So what makes this guy 0? A 0, so that's one of them. And what makes this guy 0? -9. -9, 0, and 0, 0. All right. Apparently the spacing is off because there's one more page. Last page. All right. Now here's a reciprocal function, a rational function. It says, how could have this been transformed to this? So we have a vertical reflection for that negative in front, which is across the x-axis. We have this 2, right, was a 1, so that's a vertical stretch by a factor of 2. We have this, that's a horizontal translation. I'm going to have to do these up here. Horizontal translation 5 left. And then this down here is a vertical. So vertical translation down 4. So the asymptotes are created here. This one creates the horizontal. That's y equals -4. And this one creates the vertical. X equals -5. So the domain is left and right, right? This is causing the problem. It's all reals. X cannot be where that vertical asymptote is. The range, this causes the problem for the range. All reals, y cannot be -4. Intersect, we just did this. We're going to put 0 in for x. -2 over 0 plus 5 minus 4 equals y. -2/5 minus 4, that's what, 20/5. So -22/5 is the y-intercept. 0, -22 over 5. You could change that to a decimal. X-intercept, now it's something 0. So you're going to set the equation equal to 0 and solve. So I would add 4, and then I multiply both sides by x plus 5. -2 equals 4x plus 20. And then I'd subtract 22, or 20 to make a -22. And then divide both sides by 4. So the x-intercept is -22/4, or 11 halves. So 2 goes in there, 11, 2 goes in there twice. -11 over 2, 0. All right, let's graph this. So we have -4, 1, 2, 3, 4. left 5, and normally the branches are in these two quadrants, but it had a negative on the top, which means it's here. So I just use this to help me get some points. So I go here, I pretend this is 0, 0. I go 1 to the right, so I put a 1 in there. Negative 2 divided by 1 is negative 2, so I go down 2. Boom, boom. Go back. I walk over 2. Negative 2 divided by 2 is negative 1. That's good enough. And I come over here. I go to the left. A negative. Negative 2 divided by negative 1 is positive 2. 2 to the left. Negative 2 divided by negative 2 is positive 1. I realize I skipped over that. I like to graph it. I don't know. So now the limit. As the limit of the function as x approaches negative infinity, so as I go further and further towards negative infinity, where is the graph? What is the graph approaching? Negative 4. As I go to the right, as I go towards positive infinity, where's the graph? Negative 4. Okay, guys, I hope that helped. I'll see you soon for packet 3.